Now that we have two vectors with 10 numbers each, we can try to plot them to see whether or not there is a pattern. And to help us plotting, we can use the Matplotlib library or module. So we just import Matplotlib and pyplot as PLT. This will ensure that we can use all the functions within the Matplotlib module. And if we run this, we see that we have imported Matplotlib. Now we can try to, well, firstly, we move this import to the top of our file because that's where the imports should be. So now we can use the plt dot plot, and now we can have my sequence on the x-axis and my random numbers on the y-axis. So if we just shift enter that, we see that we get this output in our interactive window. If you have another IDE or you are plotting outside the interactive window, then you should put the PLT show here in order to show the plot. As we are using the interactive window, we do not need to use this plt.show, but I will add it anyways in case other people use another IDE. So here we have our 10 numbers, the sequence on the x-axis, and our random numbers on the y-axis. But we see that the plot function by default chooses a line plot. This does not make much sense since we do not have any data points between the 1 and 2, for example, or the numbers here in the sequence. So we can write plt.plot and my sequence and my random numbers. And then we can just write O to get plt.show like so, to get like round markers here instead of the line. So here you see a much better scatter plot which is more adapted to our data set. You can also, since this anyways is a scatter plot, we can use the scatter function, plt.scatter, my sequence versus random numbers, and then we can have plt.show, which gives us the exact same result as if we plotted with these markers. Another thing is that we can save our figure. Now, when we save our figure, it's better to split our figure between the contents and the figure itself. And then we can use fig and x, which means that we are putting the output from a function into two different variables. And then we use the plt.subplots function. So now the subplots function have made a figure object and an axis object. Axis will define what we put into the figure, and the figure object is easy to save as a figure. So here we can use the plt scatter my sequence, my random numbers. And if you wonder why I can write this so quickly, I just type my underscore r and then the tab function or the tab key to auto fill the rest. And then we can use the fig object, which has a savefig method or function. And now we can save my figure.svg because this is a lossless format for the picture, which means that you can resize the figure without having problems of granularity. So, and the format has to be specified as SVG. And then we can have plt.show. Okay, so now we see that in our folder, we have this myfigure.svg. And if we open up the folder itself, we can see that we have myfigure.svg. I'm just opening this in my browser, and here you can see the figure. And this figure file you can paste into a Word document, for example, and there is no problem resizing it. So that's how you can make a plot and save the plot in Python.